26.3 VO2 max, Dan Constantine, Part 2. In Figure 3, you can see the recommended VO2 max scores for males of different ages, which signify how healthy your lungs are in terms of oxygen consumption. If we use the subject's multi-stage fitness results, he would be classed as above average compared to health norms. But for his Queen's College step-up test results, we can see that he would be classed as good. Either way, the subject is at a healthy level for VO2 max, which means that his lungs are good at taking in oxygen and using it for energy. This is needed for everyday life, as having a good VO2 max makes daily tasks easier, like walking upstairs and carrying bags to and from work. These tasks will be easier if you have a good VO2 max, as they will use up less energy, as your lungs will be able to make sure enough oxygen is getting to the muscles in order to complete the activities without getting out of breath as much. Also, a good VO2 max is a result of good aerobic training, which means if you have a healthy VO2 max, your general cardiovascular fitness will be much better, which means that you will probably have quite a healthy heart. This means you'll be less at risk of health issues like heart attacks, strokes, and heart and lung diseases. Therefore, having an above average VO2 max compared to health norms for your age and gender puts you at less risk of health issues to do with cardiovascular system and the pulmonary system. The participant has an ideal VO2 max for both his sport and for his age and gender, so doesn't need to improve it significantly. However, it is very important that he does the correct exercise and has the correct exercises and has a good diet in order to keep his VO2 max high. Cardiovascular endurance training is the most common training method for improving VO2 max, as it is known to enhance your aerobic capacity. Therefore, the subject could start with doing some continuous training, such as going on a 20-minute run at a low intensity for 4 days a week. The following week, he could increase the length of each run to 25 minutes and slightly increase the pace he is running at. The next week, he could then increase the duration to 30 minutes at an even faster pace, as it ensures that he is progressively overloading his training in order to see improvements. He can also change his running routes, such as routes with more hills, to make it more challenging so he can improve even more. He can make sure he is running at high intensities by checking his heart rate to see if his BPM is higher, as it shows that his heart is working harder to get oxygen to the muscles. Golding states that continuous training requires your body to use oxygen to produce energy, which means it will improve your respiratory system and also your cardiovascular system. He also mentions how everyday tasks will be easier as a result of continuous training, as you won't get out of breath as quickly or at all. In addition, Tinsley 2017 states that HIIT training can improve oxygen consumption, which means that VO2 max will also improve. Therefore, the participant could do 4 20-minute sessions in a week involving a range of different exercises. These exercises could be 45 seconds of battle ropes, followed by 3 30-meter sprints with a rest interval of 15 to 20 seconds, then continuous punches on a boxing bag for 1 minute with short rests afterwards before moving on to the next exercise. If the participant wanted to, they could change the exercises each session or each week in order to reduce tedium so that he stays motivated. However, the next week, the subject will need to add extra exercises or just make the duration of the sessions longer in order to ensure progression. He could also make the rest intervals shorter and increase the length of some of the exercises, such as increasing battle ropes from 45 seconds to 1 minute with a shorter rest period before moving on to 30-meter sprints. In Tinsley's article, he mentions that one study found that 5 weeks of HIIT workouts performed for 4 days per week for 20 minutes each session improves oxygen consumption by 9%. This means that if the participant continues with these HIIT training sessions for up to 5 weeks, whilst gradually increasing the intensity, he can improve his oxygen consumption by around 9% or even more, which means his VO2 max will improve, making his cardiovascular endurance even better than before. When it comes to his diet, there aren't any foods that will improve his VO2 max directly, but by choosing correct foods, he can make sure it will not get worse as long as he keeps exercising. The participants will need foods that improve their heart health and reduce blood pressure, as this means the heart will be able to pump oxygen more efficiently to the working muscles, as it won't need to beat as many times in a minute. This is because the heart will have stronger contractions, so the body gets more oxygen in each beat, which means that the athlete will be able to exercise for longer before reaching their maximum heart rate and VO2 max. Link 2018 states that foods that maintain or improve heart health include berries, leafy green vegetables, whole grains, avocados, fatty fish and fish oils, almonds, and even dark chocolate. These are just some of the foods that help heart health, but the participant may also find other foods that they prefer which provide the same benefits. It is also important that the participant does not eat too much fatty foods such as dairy products, processed foods, and fatty red meats, as it will have a negative effect on heart health and cholesterol. Therefore, the subject must stick to healthier low-fat and low-salt meals in order to improve his cardiovascular system, which will help with the VO2 max as oxygen is used more efficiently. Discussion. In this experiment, a sample size of 11 was used, 4 female and 7 male, who were all roughly the same age. We conducted 4 tests, 2 for the multi-stage fitness test and 2 for the Queen's College Step test, and the average score for each of the participants' results were calculated and put into a line graph as shown in Figure 6. The aim of this was to compare the participants' results from both tests to see how valid and reliable the tests are. This allows us to see if the multi-stage fitness test and the Queen's College Step test are valid tests for measuring a person's VO2 max, so that we know whether or not to use the test in the future. By using Pearson's rank order correlation coefficient test, it was found that the R value was minus 0.13 and the P value was 0.7 when P is smaller than 0.05, as shown in Figure 7. As the R value is smaller than the critical value and the P value is bigger than 0.05, we can see that there is not a significant correlation between these two tests. This is quite noticeable in Figure 6, as the participants' results are often quite far apart from each other. This may suggest that one of the tests significantly underestimates or overestimates the results, which is why there is such a large difference between the participants' results. In Figure 8, you can see that the mean of the Queen's College Step test is much higher than the multi-stage fitness test, which also suggests that there is not a correlation between the two tests. This may also mean that both tests are invalid, as the Queen's College Step test may be overestimating their VO2 max and the multi-stage fitness test might be underestimating it. Looking at Figure 8 again, we can see that the multi-stage fitness test has a higher standard deviation by 2.81, which could suggest that Queen's College Step test is more accurate and provides consistent results, whereas the multi-stage fitness test does not. This could be because the multi-stage fitness test is maximal, which means that participants may not push themselves as hard as they can, whereas the Queen's College Step test will always last for 3 minutes, which is why the results will not vary as much, as the participants will always do it for the same amount of time and don't choose when to drop out. In 2008, Davies et al. Conducted a study to find out the prediction of maximal oxygen uptake from submaximal ratings of perceived exertion elicited during the multi-stage fitness test using a group of 11 females. They found that the use of rate of perceived exertion measures in conjunction with the multi-stage fitness test enhances the accuracy of VO2 max prediction by the multi-stage fitness test. Therefore, on its own, the multi-stage fitness test may not be the most valid test for measuring VO2 max, but by using the rate of perceived exertion scale, you are able to make the test more accurate by asking them how much energy do they think they are using. Rate of perceived exertion makes people less likely to drop out as quickly, as they are letting the researcher know how much energy they think they are using, so they know when they are actually working maximally. This could be why the standard deviation was higher for the multi-stage fitness test, as people weren't being truthful about how hard they were working, which meant they dropped out at different times in each test, as they felt like they can't be bothered to keep going. Therefore, their results from both multi-stage fitness tests would have been different, causing variation in the data. In another study in 2004, Chatterjee et al. Conducted an experiment to test the validity of the Queen's College Step Test on 30 male participants. Their findings concluded that the Queen's College Step Test can provide a good estimation of a person's maximum oxygen uptake. This could suggest that the multi-stage fitness test underestimated the results, as the Queen's College Step Test provides fairly accurate measurements of a person's VO2 max. However, if the Queen's College Step Test provided consistently accurate results, then the participants' results would have been near enough the same from both of the Queen's College Step Tests. This was not the case, as some of the results varied quite significantly, which could suggest that the protocol was done differently, or that the test itself doesn't provide consistently accurate results. Some of the advantages of the multi-stage fitness test is that it has quite good ecological validity for ball games, like football, netball, and especially for basketball. This is because in these types of sport there is a lot of running back and forth, and we conducted the test on the basketball court, which is why it has very high ecological validity for basketball players. Another benefit of the multi-stage fitness test is that it is very cheap and easy to do, as it only requires a measuring tape and the multi-stage fitness test audio. The easy protocol also means that there is better retest reliability, as different or the same researchers will be able to conduct the test the same way. In addition, the researcher doesn't need to be highly qualified to conduct the test, as it is very simple. On the other hand, the multi-stage fitness test is not very good, as participants are allowed to choose when they stop the test, which means that their VO2 max result will not be accurate, as they did not reach their maximum energy output and oxygen consumption. This means the reliability of the test is quite low, as it is very hard to make sure the participants push themselves as hard as they can. Also, the equation for the multi-stage fitness test only takes into account the person's age and gender, whereas the other factors like weight and height will also have an effect on the participant's VO2 max. Another disadvantage of this test is that it may cause the participants to feel dizzy and nauseous afterwards, as working at a maximum level can have that effect. Therefore, maximal tests may be better suited to elite athletes, as they have better fitness and more experience with maximal exercise. An advantage of the Queen's College Step Test is that it is very cheap and easy to do. The only equipment needed is a 16.25-inch stopwatch and the audio tape, which are all fairly cheap. The protocol is very simple, as all the participants have to do is stay in time with each beat when they step up and down. This means that the researcher does not have to be highly qualified, and the test-retest reliability is quite high, as the protocol is easy to follow. Also, the equation is very simple to use, so many people can use it to work out their estimated VO2 max. Another very good advantage of this test is that it is sub-maximal and stops after 3 minutes, which means that the participants will always stop at the same time, rather than dropping out when they think they're done. This means that there is more test-retest reliability, as there is less variation in results, because the participants should get roughly the same result if they have done the protocol the same way. However, a disadvantage is that when counting heart rate manually, there is an element of human error, as they may miss a beat if their hand moves away from their pulse slightly. Also, the participant may say they counted less beats than they actually did in order to make their result look better. This is why heart monitors are a better practice when conducting this test, as human error is removed if the monitor is placed correctly on the participant. Another disadvantage could be that the researcher may use a step that is nearly the right height but is not, which could affect the reliability of the results, as the test might be slightly easier or harder. Overall, both tests have their advantages and disadvantages, but the Queen's College step-up test is more likely to provide more accurate and reliable results due to the fact that subjects choose when they're finished in the multi-stage fitness test, whereas there is a time limit on the Queen's College step test, which makes it more easy to complete. Here is the big bibliography. Here is the appendix. Here you can see a PAR-Q, informed consent, and the risk assessment for both tests.